In this video, we're going to talk about naming ionic and molecular compounds. So we'll be looking at compounds like this and compounds like this and learning to write their names like these. Right, so remember, we've already learned about our octets. So an octet is a magical number, right? And it makes electrons, it makes the atoms stable when the atoms have 8 electrons. So the closer to an octet an atom is, the more stable it is. So we had looked at an example previously how sodium does this. So sodium has this valence electron here. It has one valence electron. And what it really likes to do is it likes to get rid of that electron so that it can have 8 valence electrons. 3, 4, 5, 6, 7, 8. When it does this, it becomes more stable. Now, not all atoms can get rid of electrons like this. So let's look at another way that atoms achieve octets, because they like to do this because the octet is more stable. So that's why they're doing this in the first place, is to become more stable. So one way they do this is by sharing electrons. So these are not ionic compounds. These are what we call molecular compounds. Molecular compounds, because they are sharing electrons. Sharing electrons. So let me show you this example here. So this is water. If we look at water, we have our hydrogen atom here, and it has 1 electron on it, just this one. If we look at it, we've got another hydrogen here, same, they each have 1 electron. And then our oxygens, if we go in and count, have 2, 4, 5, and 6. Well, if we stick those electrons from the hydrogen onto the oxygen, now the hydrogen is sharing its electron with the oxygen, and the oxygen gets 8. 2, 4, 6, 8. So that electron is not only going around the hydrogen here, it's also going around the oxygen here. And so by sharing electrons, we can achieve this octet and become more stable. So one way we can get an octet is by having the electrons leave the atom, but that's not always possible for all atoms. So sometimes they share electrons like this. So that brings us to our next point, which mentions that there's 2 types of chemical compounds. So there's an ionic compound, where we have an ionic bond, where the electrons are lost or gained entirely. They just go away, or they come back. And then we have our molecular, you might also hear me call it a covalent compound, that has covalent chemical bonds, where the electrons are shared. So you can see that discrepancy here, that difference. So with an ionic compound like sodium chloride, you see the electron moves from one atom to the other atom, and they are not shared. These are not shared. The chlorine has all of the electrons, and the sodium lost that 1 electron. And then we look at our molecular compound with our covalent bonds, and we see that these electrons are shared between the 2 atoms. That's the difference here. Now, one way that we can determine whether a compound is a metal or is an ionic compound or a molecular compound is based on the substances that they contain. If we look at the substances inside each of these compounds, you'll notice some trends. So our sodium chloride contains a metal and a nonmetal. So this is our metal and nonmetal. Our molecular or covalent compounds are comprised entirely of nonmetals. Both of these are nonmetals. And so that's how we determine how we should name stuff, is if it's an ionic compound, we give it one type of name. If it's a molecular or covalent compound, we give it another type of name. And we determine that based on what they contain. Metal and nonmetal, versus all nonmetals. So let's look at how we name ionic compounds. Remember, this is a metal and a nonmetal mixed together, metal, and a nonmetal, say like chlorine. This is the chlorine gas here, contained in a glass container. So what we want to do is we want to name each element individually in the chemical formula. So here, NaCl. When you look at the periodic table, this is sodium. So we've got sodium and chloride. Or sorry, chlorine. I apologize, chlorine. So we've got our two names. Then once we do that, we want to add the suffix of "ide" to the stem of the second name, which is why I had reflexively written this as sodium chloride, because the chlorine turns to sodium chloride. Okay, so let's look at another example. Say we have magnesium and oxygen. This ionic compound will look like MgO if you write the formula for it. So magnesium and oxygen, we're going to take that ending and we're going to add "ide" to it. So instead of oxygen, we're going to turn it into magnesium oxide. Okay. Here's another example, calcium and sulfur. So we put these together, calcium, sulfur. Instead of sulfur, we're going to go sulfide. Sulfide. Simple enough. Now things can get a little bit complex every now and then. So let me get this out of here. So hopefully you have that calcium sulfide written down. All right. So transition metals can be a little bit problematic here because transition metals have more than one oxidation state. So when we're naming them, we have to describe this. So we can do that by indicating it with Roman numerals. So say, let me see if I have an example here. Okay, so FeCl2, FeCl3 are different compounds. They're entirely different substances, so we have to name them differently. So this one would be iron. So iron 2 chloride for the first one. I can't spell. Chloride. The second one, because it's got 3 chlorines, iron 3 chloride. So whenever you're naming stuff and you see a transition metal, stop and think about your oxidation numbers and your oxidation states because you're going to need to put these numbers in here. So pay attention to transition metals very closely when you're naming ionic compounds. Okay, so go ahead and give this a try yourself. You can use the periodic table below to name each of these individual compounds here. I've indicated for you that this one is Cu2, so you'll know the oxidation state that it's currently in. Let's look at the answer for this one. So Ki, if we look at the periodic table here, we've got a potassium and an iodine. So potassium and iodine is going to go to potassium iodide. IDE is the ending we're going to add. Mg3P2, we're going to locate that on the periodic table. Magnesium, phosphorus. So magnesium, phosphide. CuCl2, so Cu is here, it's copper. Cl is here, it's chlorine. So this is copper because it's in its oxidation state of +2. It's copper 2 chloride. We're going to learn later on in this video how to determine this oxidation state. So we'll talk about this number a little bit more in depth as we continue. Let's look at how to name molecular compounds. Molecular compounds consist of 2 nonmetals or metalloids. You might see those incorporated as well. Again, metalloids are kind of a gray area. On an exam, don't expect to get metalloids very much in your, or to get tested very much on metalloids. They will most likely not appear because sometimes, again, they can be named as like a molecular compound or an ionic compound. They kind of tiptoe in between there because they're really weird. So most of the time, it'll be very clear that you have a metal and a nonmetal or two nonmetals. All right, so whenever we do molecular compounds, we have a difference here. We use prefixes in order to indicate the number of each of the atoms of the elements present in the compound. All right, so in order to do this, here are the steps. You want to name each element individually. We're going to add "-ides" to the ending, the same way we did for the ionic compounds. But now we need to add this use of prefixes in front of each element. Oftentimes, we will omit mono on the first element. An example of this is, let's see. I'll show you an example. So carbon monoxide is a great one. So CO is the formula for this. And so you'll notice that this one's called carbon monoxide. So it should be monocarbon monoxide because there's one carbon, one oxygen, but we've omitted the mono in front. So it is optional. We usually don't write it. Okay. CO2. So maybe I have carbon monoxide as my next example. So CO2, carbon. Instead of carbon monoxide, we're going to use this prefix for two atoms. So carbon dioxide. All right. N2O. Let's look at this one. So this is an example where we don't have mono on the first one, so it's not omitted. So N is nitrogen. So we've got a nitrogen. So let's use these steps. Nitrogen and then oxygen. We're going to turn that ending to an "-ide, so nitrogen oxide. Okay, now let's look at our prefixes. We've got two of these and one of these. So this is dinitrogen monoxide. Okay, so you put your prefixes in there after you've added the "-ide ending. Okay, so that's how you name molecular compounds. So give this a try on your own. See if you can use this periodic table down here and these prefixes here in order to name the following two molecular compounds. So let's look at the answer to this one. Our sulfur is our S, so it's here on the periodic table. O is oxygen, it's right here. So you've got sulfur and oxygen. So we've got sulfur, sulfur. Oxygen goes to oxide, oxide. Now let's look at our prefixes. Sulfur, there's only one of these, so it would be mono. Because it's in the front, we're going to omit it. And then oxygen has three, so it's a tri. So sulfur, trioxide. Let's look at this next one. Bromine, Br, is down here. So that's Br. Cl is chlorine right above it. So we have bromine, bromine. Chlorine turns to chloride. Now let's look at our prefixes. We've got a 2 and a 6. So we're going to use the 2 and 6 prefix, which is di. So dibromine, 6, hexa, hexachloride. So the final name would be dibromine, hexachloride. Let me know if you have any questions about this.